Good morning, everyone. I'm Tanakram.
I'm Athar Gupta.
I'm Gayatri.
And I'm Amika Charani.
We are Team Fasal Sanrakshaks from Grade 7 Salvan Public School, Gurugram. And today we are excited to present our project, the Fasal Sanrakshak app. Our goal is simple yet very powerful to protect India's crops using artificial intelligence.
Let me start with a story. Once there was a farmer named Ramesh. He worked all day long, caring for his crops with love and dedication. Every day he woke up before sunrise and worked till sunset. His fields were his life, his hope, and his pride. But then came the dark days. A mysterious pest crept through his fields, slowly destroying everything he had worked for. And when the day of harvest finally arrived,
There was nothing left to harvest. This is not just the story of Ramesh, it is the story of millions of India and billions around the world. This isn't the tale of the past, it's the harsh reality. Every year, countless farmers face the same heartbreak, losing their hard earned crops to unseen enemies like pests and plant diseases. What seems like one man's struggle, in truth, is the voice of millions. Farmers whose hopes and dreams are shattered with every failed harvest.
According to the Food and Agriculture Organization and World Bank, around 46% of India's population is still dependent on agriculture for their livelihood. That's almost half of our population. Every person in two that you meet is a farmer. And according to the Food and Agriculture Organization of the United Nations, up to 40% of global crop production is lost annually due to pests and plant diseases, which is around a staggering $300 billion each year.
According to a study published in Nature Ecology and Evolution and data from the Food and Agriculture Organization FAO, estimated global yield losses due to pests and diseases for major staple crops are approximately wheat 21.5%, rice 30%, maize 22.5%, potato 17.2%, soybean 21.4%. Now that you have understood the challenge, here's how we decided to tackle it using artificial intelligence.
our objective was to create a machine learning based system that can detect crop diseases from leaf images. We developed a simple web app that works on both smartphones and computers and can tell whether a plant is healthy or infected and even identify which disease it has. Through this, we support the Viksit Bharat vision, promoting smart, technology driven agriculture, reducing crop losses, and improving rural productivity through innovation.
To make this possible, we used Python as our programming language, machine learning libraries like TensorFlow and Keras for building a deep learning model, the Resonant 50 architecture, a powerful base model for image classification, which I will explain in the next slides, the plant village dataset with 38 different plant disease classes, Google Collaboratory to train our model, Django for our backend web development. We use GitHub and Git for our version control. We use HTML, CSS, and JavaScript for building our front end. And finally, we hosted a prototype on Render for easy online access. These technologies together make our solution both smart, secure, and scalable.
Here's how we built the model. We first found a suitable dataset on Kaggle.com. It was a plant village dataset having 38 disease categories and a total of 14,000 images. We resized and pre-processed the image dataset using Python Pivot library as required by the model.
We have trained a powerful image classification model on Resnet 50, which is a neural network with 26 million parameters. In simple terms, parameters are knobs and dials we tweak to improve the model accuracy. For context, GPT-3, the third version of ChatGPT from OpenAI, has 175 billion parameters, which makes our model around 7,000 times smaller than GPT-3.
Then we trained and evaluated the model. We leveraged Google Colab cloud computing capabilities to train the model. We used 80% of the 14,000 images in the dataset for training and 20% in the plant village dataset for testing. We trained a model for 30 epochs or iterations. This simply means how many times the model goes through the training data, learning better each time. The training time was 5.5 to 6 hours.
Once the training and testing was complete, we developed a mobile first web app using Python web development framework Django and hosted the prototype on render.com for live demo.
Here's a visual representation of a CNN model, Resnet 50. Think of it like a powerful brain. It starts with an input layer, ends with an output layer, and has 59 hidden layers in between that can do all the learning magic. To make this easy to imagine, let's take a small image. Just 30 by 30 pixels, which makes 900 pixels in total.
Now every pixel is made up of three colors red, green, and blue RGB. Each one has a value between 0 and 255, and when we divide them by 255, all the values shrink down neatly between 0 and 1, ready for the model to understand.
Each pixel value is sent to a neuron in the input layer, one neuron for each pixel. So that's 900 neurons. Each neuron connects to the next layer using weights and biases. These start off completely random. The model mixes all these numbers, passes them through every layer, and finally reaches the output layer.
But here's the twist: since everything starts off random, the final predictions are just random guesses. We use a function called softmax to turn those numbers into probabilities, and that's our first output answer.
Of course, the results are usually wrong at first. That's where the loss function steps in. It basically tells the model, oops, that was wrong, try again. Then comes backpropagation, which helps the model adjust and improve each time. Like practice makes perfect.
After many rounds of learning, our model reached an accuracy of over 95%, and that's when we used it in our website.
And here's the result. This graph shows our accuracy climbing higher with every epoch. You can see it improving steadily until it hits around 95%, where our model finally became ready to make real predictions.
Our solution helps farmers detect diseases early, saving their time, effort, and resources. It can reduce crop loss significantly and promote sustainable agriculture.
The line shows how our accuracy gradually stagnated around 95%. This was due to a lack of proper training data, as we could not have that much data. In the future, we aim to add multilingual features for regional access, support for keypad phones, an offline mobile app version, and an AI chatbot to provide tips and guidance. We also want to add a voice mode so that even illiterate farmers can use our app and nobody feels left out, because we want Fasal Sanrakshak to be a true companion for every farmer.
Our project directly supports the Viksit Bharat 2047 vision by encouraging smart agriculture with AI and digital empowerment in rural India. It promotes Atmanirbhar Bharat by making farmers self-reliant and vocal for local by using locally collected data for training our models.
By improving productivity and reducing losses, we're contributing to Samrit Bharat, a prosperous and sustainable India.
Thank you for your time and attention. We hope you enjoyed learning about our project as much as we enjoyed creating it.
We are open to your questions and would love to share more about our work. Once again, we are Team Fasal Sanrakshak, protecting India's crops through the power of AI.
Thank you. Jai Hind. So now we are going to show you the prototype demo.
Welcome to the Fasal Sanrakshak mobile app. This app quickly checks whether a plant is healthy or not using a single photo. It also identifies the plant species with a high accuracy. It works smoothly on any mobile device, making it easy for farmers to use directly in the field. The app includes an About Us page where users can learn more about a team and our purpose, and an About Project page that explains how we build the solution. Fasal Sanrakshak aims to bring simple, smart plant checking to everyone.